Hi guys, today another session for our video series tutorial for PLC ladder logic programming. And today we will start actually after installing last time we have installed the software for TIA portal for Siemens and the simulator. And today we will start to our session today to start the PLC ladder logic basics and component. So before we start, just brainstorm together to let's think what is a component you will see in ladder logic. And to start this, we need to talk about the similarity between ladder logic and the circuit diagram for any electrician. As you can see here in the screen, you can see two wires, one on the left which represents the live wire and one on the right representing the neutral wire. And in between the live wire and neutral wire, you will find the circuit. Like this circuit, starting with a stop switch. And this switch for sure it's normally closed, and when we say normally closed, meaning the default at the start it will be closed to connect the circuit. And then the next one is the switch for normally open, which is the opposite of the normally closed. In normally open, you start initially with the circuit is open, the switch is open, and the user will hit this button to connect the circuit. So as you can see here, when we push this start button, the circuit will connecting from the live wire to the output, and the output here which called the C for a coil, and the coil here like for a motor. You have a coil in the motor, and this coil of the motor, by energizing this coil, by connecting, by hitting the start button, we connecting this coil by the electricity between L and N. So that's the traditional circuit for connecting a coil, a simple coil or a motor with electricity. So same thing in ladder logic. It's similar to the conventional technique of connecting a wire. That's why all technician and all engineer like this language, because it's very near or very close to what they do in their circuitry connection before. So here, when we talk about ladder logic, so it is ladder and it is logic. Ladder because you can see it is like the ladder has two lines, one on the left which is representing, as we have said, the live wire, and one on the right which is represents the neutral wire. And in between the lines of the ladder, each line we call it here rung, and this line representing one circuit. And this circuit, the target is to connecting the input switches or input sensors in a way to transfer the power from live wire to the neutral wire, and let the output, which is a coil or lamp or motor, to be energized based on the logic we want. So now we talked about the ladder, but how about logic, ladder logic? So logic meaning that the way we connect the inputs together in a logic form to represent the philosophy or the logic we want to let the output to energize at a specific situation. So here in this screen you can see the logic gates for AND, and you can imagine here it's the same thing like when we have an AND logic between, we have two switches. Imagine we have two switches and we want to connect these switches in a AND logic to energize one motor. So the condition to have this motor to be energized is to have both of them, A and B, to be switched on to let the connection of the power going through the coil of the motor. So in the first column here, you can see the name of the logic gate, which is and the symbol in the second column, and third column showing the representing of ladder logic. Same thing, like we connecting in series A and B, switch A and switch B in series, meaning it is ANDed together to make an AND condition or AND logic to switch on one load. Same thing in the second row for the NOR. In the NOR logic, you know, it means A or B. So one of them is on, meaning the output will be on. So here you can see in the third column the ladder logic. So A and B will be in parallel. So you can compare and never forget this thing. Like when you want to make AND logic, you connect your inputs in series. When you want to make NOR logic, you want to connect them in parallel. And the last column for sure, it is the truth table, showing the combination of the situation we can have by this connection. Like you can have a situation because you have two inputs, so you have four situations. Either both of them switched off, one of them A is switched on and B switched off. This is the second case. And the third case, when A is on and B switched off, or the last case, which is the fourth case, when both of them are switched on. Same thing for the NOR. So for two input logic gate, you need to know it will be four condition, and you also need to know it is connecting switches or inputs in series in ladder logic. And same thing for NOR, because we have two inputs, so we have four situations, but the difference is to represent this in a ladder logic, you connect your input or switches in parallel, as you can see. So moving very fast before going to what you love, you and me, which are going to our lab to simulate something or doing some practice. So here a very simple rung showing the contact I1, which represent to the input and the output Q1. So by having this input switched on, the output coil Q1 will energize and will be of logic high. So here everything you might see in your ladder logic program before we're getting started and writing some codes. So the switches or the input represented by a contact, as you can see, two cases for the last contact. So normally open and normally close. Normally open, as I have said, just you have it initially open and disconnect the circuit, and the incoming state, it will be to connect by pressing a push button or switch or something like this. The opposite for normally closed is true, because it starts initially connecting the circuit, and by hitting or turnover, it will be disconnecting the circuit. And here on the right, you can see symbols of rungs. As you can see, this is a ladder. We have left and right hands, and we have branches, and each branch represents one circuit, and we call it rung. So guys, now this is our sample that we wanted to make today for practice and hands-on in programming ladder logic. So here we have one input for start, or we call it run, and it will be connected to address I0.0, and notice here we writing the percentage sign before the address. So the format of writing address is the percentage size, and then character I for input or character Q for output, and then 0 representing the slot number, and dot and finally the number of the point or the channel within this slot. Okay, next one is the stop button, which normally closed here, and we give it percent %IO.1 0.1, and the motor is the output. We represent it as the address percent %Q 0.0. So let's move to our software to represent this simple one. So now we opening TIA. I just try to open it one more time to let you familiar with the software. Okay, but next time I will go directly to the program for saving the time. So here we'll open like this is the first program we have done last time. So we'll use the all configuration to save the time and talk about the this program and practice the simulation with this program. So now the program is opened. So we go to the program block, and as I showed you last time, we have one main in the program, and this main contains the main program, and I will show you later it will be functions or subroutines that might be including with the program block, and show you how to call this routine. But now let's do the logic. So the logic here, or the very simple program here, is one input for start, one input for stop, and one output, which is the coil. So here this is the input number one, and let's show you here, right click and then rename the tag and make it like run. Okay, and same thing here we'll add. So here in the ladder logic, you can see we have normal contact, normal open contact, normal closed contact, coil, and this is a block I will show you. In this block you can write other programming functions, and we'll go later with it. And this one is to branching, like doing a branch, and I will show you here how to make a branch. Okay, so let's start with adding another contact for the other input, which will be like percentage I 0.1. Okay, and let's name this one to be stop, and this one Q00 is the output. Rename it to motor. So now we complete our program. So this is representing a very simple program for the AND. So the condition to have this motor to be run, to have both of them are on, A and B, all run and stop in his normal condition, normally closed condition. Okay, so let's make the OR. Okay, let's make the OR also, which is a parallel. So here we adding the first input, and we here make one branch, and then make the other input, and then close this branch to up. So now we have two parallel input, and we will have also this one we can copy and put here best. I'm doing a combination of using the software, trying to use everything like a normal programmer. He knows everything about the tools, so I am trying to one time make copy, one time make adding or creating, to let you see more and more of the tools. So let's make this one like I 0 2, and make this one I 03 2 input, and this is the stop, same stop, and let's make another output because we need to simulate both of this run. So this is another one. Let's make it lamp, and here let's name this as input A, and this one to be input B. So now we need to simulate this thing to make sure the logic of this thing. So we just here start simulation. And you can see automatically it will be connected to the simulator and the download. And the same thing, if you connect it to your real PLC, it will go through same process, like connecting and loading the program. And let's start the code and click finish. By the way, brothers, you can pause the video at any time and go replay back and forward to and make sure you understand everything, or repeating something I have said to make the most benefit of my video. So here, as you can see, I downloaded the program and it is now simulator connected. So let's simulate and see. So here you can see here. So this one green, meaning it is already connected, it's true. So for that motor to be true, what we need is to run this switch on. So if I collect this one and say on, same thing like before. So let's open this one like this. Okay, so brother, now we're creating a simulation program. Let's minimize this one and prepare this one, yeah, to be like this, and this one also after completing, yeah, yes. So now can open this here, yeah, still working, yeah, loading a configuration, loading from here to there. Okay, so now as you can see here, we can open this one, and this is the device configuration, and this is the data. So we can add our run here to watch what's going on, and this is our motor, the output of the first run, and this is input A, and this is input B for the second run to show the OR logic, and this is the output, which is the lamp for the second one. So let's say in the first one. So now if you can see here, you can see the status false, 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 all of them is false. So good question I hear from you now, why this one it's false and it gives green? Well done. Yes, because it is normally closed, so it is the reverse of the logic itself. So if it is true, so not true equal false. So that's why when it is false, so not false equal true, meaning it is green. Okay, so now let's make this run to be on. Okay, so I just make this one to true, as you can see. So now the condition for AND is established. I have this one is okay, this one is okay, so this one has all condition ready, so it is run. If I hit this stop, if we didn't add one for the stop, so if we have this stop, okay, this is this stop button. So if I make this stop button in changing from false to true, so it will terminate the condition. And then as you can see, so let's try the parallel one. So the parallel one, if we have only one condition, which is, let's say close this one at least for not confusion. So if you have one condition which is A and they make A true, so at least one, not need like and the both inputs to be realized. One of them make it is on for this one. And same thing for this. If both of them true, I'm sorry, this is the stop. I'm so sorry. So this one is the two input. So if both of them are on, so the output is on. But if at least this or this, it will be on. But if both of them are off, then the condition is not realized. Thank you guys. I hope you enjoy this session, and let's meet very soon to go through a new thing and learn and practice together as usual. Thank you.